So hello everyone, I hope you all are well and making progress in life. Here is Priyanshu and welcome to the Infinity Mind. So today we'll be solving the problem M coloring. So here we can see that we are given just an undirected graph consisting of V vertices and E edges represented by this edges matrix, and we are given an integer M which denotes the different possible colors, number of colors. Okay, and we have to use at most m different colors such that no two adjacent vertices share the same color, and we have to return true if we can fill the graph with the at most m colors, otherwise false, and the graph is indexed with zero based indexing. So we can see that in the example one also, that in input we can see that we are given v as a number of vertices, and edges matrix is given telling us how the nodes are connected, and m different colors are given. So we can see from example one, if we draw the graph, the graph is like here, and now we have to tell that in these v nodes can we fill m different colors, at most m different colors, such that no two adjacent nodes are of same color. No adjacent nodes are of same color. All right. So we can see that we have three different colors here, and if we color 0 with red, 1 and 2 with blue, and 3 with green, we can see that no two nodes, no two adjacent nodes here are of same color. So we can see that we can return true here, and we can easily see that our at most m colors are also used. All right. So now how we can solve this? So I have taken an example, the example one same here. We can see here that the nodes are four, and colors, let's say, are in this example three colors are given. Let's say color number 1, 2 and 3 are the colors, and initially all the colors are zero. So I can take a color matrix to define the nodes of colors of nodes. All right. So there are four nodes. Indexing is zero based. So initially the color of all the nodes is zero. All right. Now how I can proceed? So what I can do, I can start with the zeroth node. So if I color this with red color, let's say three color are given, and let's say if I color it with red, and before coloring it with red, I should also check that adjacent nodes, that is 1 and 2, are of different color. So yes, we can see that 1 and 2 are of different color because they are of color 0. 1 and 2 have 0 color, and uh, the color which I want to fill, that is red, let's say is 1. All right. So we can see that no two, if I color this with red, no two adjacent nodes are disturbing. All right. So yes, I can fill it with red. Now I will proceed with the next node. Now I will go and try with the next node, that is node number 1. So here again I will, what I will do, I will check for, if I am at node 1, let's say first I was at node 0, I checked by filling either color 1, either color 2, or either color 3. So I was able to fill this node 0 with color number 1. So I will not go and for color number 2 and 3. I will proceed here. Now if I have filled this node 0, now I will go to next node, that is 0 plus 1, previous node plus 1, that is one node, and now again I will try that can I fill it with 1, can I fill it with 2, can I fill it with 3. So can I fill it with 1, that is color number 1, that is red? No, because adjacent node is already filled with red. So this is not possible. Can I fill it with 0? Can I fill it with 2? So let's say my color number 2 is, let's say, yellow. So yes, I can fill it with yellow because no adjacent nodes are of yellow color. So yes, we can fill it with 2. Now I will not check for 3 because we have to return any possible answer. So if I am able to fill colors, so I will return that. I will not check for all possible answers. I just have to return one possible answer. Now again, I will, if I have filled this f of 1, I will go and fill the second node, that is node 2. Now again here I will check either can I fill with color 1, can I fill it with color 2 or 3. So can I fill it with color 1? So color 1 was red. No, I cannot fill because adjacent node 0 has already red color. Can I fill it with color 2? Uh, can I can I fill it with color 2? So color 2 is yellow. Yes, I can fill it with color 2 yellow because no adjacent node is of yellow color. All right, so I can fill it with color 2. So it's okay now. Now again I will try to fill the third node. So again here I will check 1, 2 or 3. So can I fill it with color 1? So it is saying that can I fill it with color 1, that is red color? No, because this node is directly attached to 0 and it is filled with already color number 1, that is red. So I cannot fill. Can I fill it with color 2? Color 2 was 2. So adjacent nodes are already of color 2, that is yellow. I cannot fill. So now here I have to choose color number 3. Let's say our color number 3 is, let's say, green. So yes, I can fill it with green color, and we have total 3 colors also. So yes, I can fill. So now I will go and check for this fourth node, and now we can see that there is no fourth node here. We can see that there is no fourth node here. So now we can see if we have reached the fourth node, that is nth node, that is vth node. So it means that we have already filled all the nodes. So yes, we can say that we have got an answer and we will return true. All right, and we will return true, 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 true. And in this case, answer will be true. So this was the logic. And if I go and implement this, so first of all, what I was doing, first of all, we can see that edges are given. So first of all, I should create a graph. So I'm using an ordered map here for creating the graph because it's in my habit. So I am creating a graph here. All right. So let's say this is graph, and now I'm creating graph here. So we all know how to convert this edges matrix into undirected graph. So what I will do here, edges I am getting. So u will be what? E of 0, and v will be what? E of 1, E of 0 and E of 1, because edges are containing 0 is connected to 1. So it's 0, it's 0, U is connected to V. Alright, so I can say that map of U dot push back U push back V, and similarly map of V dot push back U. This way I am storing that 0 is connected to 1, 2 and 3, and 1 is connected to 0 and 3 through a map. So yes, this is also a graph. All right, so now what was my next task? So what I have to do, I have to start from the zeroth node. So what I will do, I can just call a solve function where I will be passing the zeroth node first, where I will check, I will pass the graph, and also I will pass the number of nodes and the number of colors, and rest we will see that what is required, and we will just code it. Now what our solve function is doing, that first of all it is taking a node, which node we are just checking. So let's say node, then we were passing our map. So I will be passing with reference. Next I was passing the number of nodes, and next the number of colors. Now here what I will do, first of all I will write the base case that whenever my node is equal to v, then I will say that I have to return true from here, because I have reached the last vth node. It means that I have covered all the nodes and colored them, so I will return true. In the else case, what I can do, that I can try filling it with different colors, starting from color, starting from 1 and going up to m. Now I will try to fill the current node with the given color. So first of all, before filling, I will check that is it possible to fill this color, this node with this given color or not. Is it possible to fill this 0 with red color or not? So I will ask, I can just create a function is possible, and there I can pass color and node. Also I need to pass the map also, and let's say v and m also, and later whatever we will need we will just add it. And if it is possible, then what we have to do, if it is possible, let's say I filled this with 0 with red. Now what I have to do, I will just, if it is possible, first of all I will create a color array. So there I will say that node of this color should be filled with this color. All right, and now I can go and ask solve call the solve function, where I will be calling the next node, and the map and the v and the m. And if it is true, if it is true, if it is true, if this comes to be true, all right. So if this, after calling the solve function, if it comes true, what I can say, that just return true, all right, because it means that I have filled all the nodes, all right. And if it is not true, then what I can say, that it will automatically go and check for the another color. And yes, uh, what we what we have to handle one case, that suppose I filled this with this node with color, any color, let's say col, the ith color, and I have asked the solve function, I've called the solve function, and if it is true I will return true. But let's say after returning, so let's say this is not true, all right. Let's say if it is not true, I have to undo the operations. I have to say that again make this node's color with 0, alright, because now it will try with another color, alright. So now one thing we have to add here, the color vector, and this will be of size what? How many nodes are there? V nodes are there, and initially I have to fill all the nodes with the color number 0. So I should pass the color vector also here at the end, and here in the function also I should pass here color by reference, and here also if I'm calling uh, the yes, I'm checking if it is possible or not. So I should pass the color vector also here, and in the solve function I should also pass the color vector. Now if it doesn't return true, at last we can say that it means that we haven't got any answer, we can just return false. And now I have to just write the this possible function where what we were passing so many things. First of all, the color, and next the node, next the map vm, map pm, and the color. Same things we were passing here. We can just reduce also if something is unnecessary here. So yes, we have passed carefully. And now how we will check that if it is possible to fill this node 0 with red color or not. I can just use my this graph, this map, an ordered map where I have stored that what are the neighbors of 0. So I can just go to the neighbors of 0, nodes of 0, neighbor nodes of 0, adjacent nodes, and I can check that whether I am able to color this with different color or not. So I can just check by just using a different function is possible. And what I can do, I can run a for loop, and this will be, let's just see, and it will be roaming around the all the connected nodes to 0. So map of node will be storing a vector. Map of node will give us a vector where all the nodes will be stored. Map of node will give us a vector where all the connected nodes to 0 or the current node will be stored. So now we will just ask that in the vector uh, we are using a for loop. So this for loop, this C will tell us the all the connected nodes. So this will give, if I take the example, the current node is 0. So this for loop, uh, this C will be giving us 1 and 2. So I can just ask that if color of that this color vector of this C connected node is equal to the COL color that we want to fill. If any of the nodes have color red, so we can just say that no, we cannot fill this color. It's not possible. Otherwise, at last, we can just return true. So now I think we are good to go. But before that, we should check if we are not missing any H case. So if I submit this and check that whether I haven't made any mistake, and so yes, we have solved this problem successfully. And now if I talk about the time and space complexity, so we can see that we have V nodes, all right, and we have M different colors. So what we are doing, we are trying on every node. In the worst case, we are trying all the possible colors. So in this node, we are trying to fill M colors, here also M colors, here also M, here also M. So V nodes are there, and at every node we are trying M possible colors. So time complexity will be big O of V to the power M in the first case. So time complexity will be V to the power M in the worst case. Alright. So yes, inside we are using a for loop also, which is telling us the is it possible or not, and we are running a for loop. So yes, overall we can see that in the first case V to the power M time complexity will be there, and space complexity we can see that we are using an ordered map to store all the vertices, and we are using extra space for the color vector also, and yes, we are just using this map and color. So this color array will take space of uh, number of nodes, and map will also take the space. In the worst case, 0 will be connected to all the nodes, then 1 will be connected to all the nodes. So this will be taking V into V. So the space complexity will be big of V into V plus the plus V. So so this was all about this problem. I hope you understood. Thanks for watching. Till then, keep learning and keep upgrading yourself. See you in the next video.